S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
So in part 1 of this lecture, we did series, geometric series, P series, convergence, and the necessary condition for convergence of a series. In this part 2 of this lecture, we'll be understanding or we'll be discussing two important tests. If we are given any series, then how to check convergence and divergence of that particular series. Hello everyone, welcome to S. Chand Academy. I am Dr. Seema Thakran. For engineering mathematics, please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. So first, I am discussing the very important test, that is Cauchy's nth root test. And what exactly this test states in terms of convergence and divergence of the series. So let summation un be the series, be the positive term series such that limit un whole power 1 by n is L, then the series converges for L less than 1, diverges for L greater than 1, and the test will fail, this Cauchy's nth root test will fail if it means this test is also has the drawback if L coming out to be 1. But if L is some number and that is less than 1, we can surely say it is converging, and if L is greater than 1, we can surely say that L is your series is converging. So now on Cauchy's nth root test, I am taking one example, and my example is check the convergence of the series, and my series is summation n to the power whole power n. So the terms of the series are in powers form. So whenever you have series terms in powers, better first you apply the Cauchy's nth root test. So as per the Cauchy's nth root test, my series is this. If I just take the limit of the nth term, limit to the power 1 by n, so what I'll get? Limit, my nth term is n to the power 1 by n minus 1 and into 1 by n, and n will get cancelled. And if you see the limit now, it is 1. This we did in our limit concept, where we did the limit finding, that you can refer for the limit. Ultimately it is 0. It means this is less than 1. So what does this state? By Cauchy's nth root test, the series converging. The series is converging. So this is how you apply the important test, where that is Cauchy's nth root test. Now coming to the another important test, that is D'Alembert's. So D'Alembert's test statement is, if summation un is a series and limit un upon un plus 1 is some L, then series converges for L greater than 1, diverges for L. You need to remember for the L value, because for Cauchy's nth root test, if it is less than 1, then it was converging. But here for D'Alembert, un by un plus 1th limit, if you are getting as L, then for L greater than 1, it will converge. In some of the books, you find the limit, and for let me discuss for For L equal to 1, the test fails. In some of the books, it's not that it is wrong, but in some of the auditor, I'll write it, another statement. If limit, I'm just reversing the ratio. If it is so, then obviously this will get changed. So for convergence, L less than 1, divergence, L should be greater than 1. So this is how, if you are taking this ratio, then you follow this for convergence, divergence. If you are taking this ratio of the limit, then follow this for convergence and divergence. I'll be taking this ratios, that is un upon un plus 1. So for greater than 1, it will converge. So one example based on this. So the example is, check the convergence of summation un, that is 1 upon n this. So what exactly the series look like? Just vary the value of n. So 1 by 2 plus 1 by 2 into 2 square, 1 by 3 into 3 cube, and so on. This is the series which is given, but this is in summation form, and I have expanded this summation. So first term you can see, then second term and third term. I am applying the D'Alembert's ratio test. So I'll take the limit of un upon un plus 1. So 1 upon n, 2n. What will be n plus 1? Just replace n by n plus 1 in the nth term. So finally my expression is n plus 1, 2 to the power n. It will go in numerator and the denominator will be this. Finally, I have to take the limit. So limit un upon un plus 1. This will be 1 because this n you will take out common and it will give you 1 plus 1 by n. Then n will get cancelled, and this is just only 2 because 2n will get cancelled. So finally the limit is 2 because this 1 by infinity is 0, 1 into 2 is 2. This is greater than 1. So as per the by D'Alembert's ratio test, the series converges. So this is how you apply the D'Alembert's ratio test, and if L is greater than 1, it is converging. Okay. So we have discussed two Cauchy's nth root test, D'Alembert's test. It's not that these are the only tests, but these are the very important tests. Anyhow, any series is given, you can apply, and for only if the limit value is coming out to be 1, these tests are failing. Otherwise, and we don't have any other substitution for that. It means further research we need to do for finding the convergence if the limit is coming out to be 1. So in part 2, we have discussed D'Alembert's ratio test and Cauchy's nth root test to check the convergence and divergence of the series. We did discuss the statement, and we took examples to understand the theorem, the test for the convergence and divergence. For engineering mathematics, please refer to the book by S. Chand Publishing. The book is very good, and you find the concepts very easy explanation for the questions, for the theorems, for the concepts. So please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. Please like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching the upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.